It's a problem that affects human and autonomous drivers the same. Neither can see through the fog. Well, MIT researchers have developed a novel new imaging system that can see through fog so thick that human vision can't see through it. It can even tell you how far away the object is. The work is an important step towards the development of reliable vision systems for autonomous cars. Unclear driving conditions have been one of the biggest obstacles in the development of self-driving cars. Until now, other imaging systems performed worse than the human eye. For their proof of concept, the MIT researchers used a time-of-flight camera that shoots bursts of laser light and measures the time it takes for the reflections to return. The system could actually see objects that were more than 50% further than anything the human eye could see. The difference is an algorithm that they developed, which uses statistics on the way fog typically scatters light. Using the algorithm, the camera could separate the light reflected from the object from the light reflected from any density of fog. The camera is taking measurements every 56 picoseconds. That's every 56 trillionths of a second to create an image of what's in front of the car during bad weather. Now, if we could just figure out how to get cars to see pedestrians at night, we'll really be onto something. But that fog. We got the fog. Hey, neat. You wear the Tobii Pro Glasses 2 wearable eye tracker just like a normal pair of glasses. It watches everything you do. The only thing that's different is that it records it. Think body cams for industrial professionals. And instead of, being on your body, it's on your face. The glasses are pitched as an excellent training tool, a way to cut down training times and improve safety. The company did a case study with workers at the H.H. Castings Metal Foundry in Pennsylvania. And it was a fitting example because bad things can happen fast when you're working with molten metal. The Tobii Pro captures video that is unlike any training tool before it, because even if you're shadowing a person, you still have a different perspective and don't necessarily know what they're looking at. It's kind of like when my brother is shouting and pointing at a certain piece when we're installing a ceiling fan. I just have no idea what he was looking at or talking about. Should have had the Tobii Pro Glasses 2. Thumbs up. Hey, neat. Dave Manti says, neat. Should have had the Tobii Pro Glasses 2. Should have had the Tobii Pro Glasses 2. Why do I have such short thumbs? It's a little scary because it could also enable management and HR to essentially break down the tape and give you a play-by-play analysis of your workday. However, according to a company spokesperson, for now the eye trackers are strictly for research purposes, only within the set parameters of a scientific study. Anybody participating in a study would need to give their consent before being eye tracked. Unless, it's obligatory in the contract you sign with the company. Just saying, it's a possibility. The University of Nebraska used eye trackers to study human error on construction sites. They were actually able to come up with a reliable model for predicting human error and preventing subsequent injuries on job sites. Some sports teams are now using the technology to study player performance. And you know what it would also be good for? YouTube tutorials for basically anything. I have no idea what any of you guys are talking about, even though the camera is zoomed in right on the product. What are you talking about? Hey, neat. Sophie is a new soft robotic fish that can swim among real fish in the ocean. It was created by a team of researchers from MIT's Computer Science and Artificial Intelligence Lab, or CSAIL. Man, MIT is killing it this week, and they actually made a point of saying that it can swim beside real fish. What the hell else is it swimming beside down there? Until now, autonomous underwater vehicles needed to be tethered to a boat or powered by large propellers. They're big, bulky, and are even a collision risk. Sophie could signal a softer, tether-free future once the researchers make it capable of automatically recognizing and following fish. Until then, researchers actually control the extremely high-lead sushi using a hacked Super Nintendo controller that communicates using ultrasonic signals. Well, it's actually a Buffalo Classic USB gamepad, but it's cooler to say that it's an old Super Nintendo controller. Otherwise, the components make for a much lighter biomimicking vessel. Using a fisheye lens, Sophie can take high-res photos and videos at depths of more than 50 feet. And a small lithium power battery, similar to the one in your smartphone, powers it for up to 40 minutes. A hydraulic pump moves the tail, urethane foam chambers make it buoyant, and a motor pumps water into two balloon-like chambers in the fish's tail that work it like a set of pistons. Next, the team is going to work to make Sophie faster by improving the pump system and tweaking the design of its body and tail. They also hope to find a way to make the fish use the camera to automatically follow analog species in the sea. Look for Sophie in an upcoming episode of Black Mirror, where she likely kills all of the animals in the sea and causes the Earth to die. What if one day someone actually catches one of these things? Are they gonna keep it or throw it back? I guess that's Sophie's choice. I'm David Mantey. This is Engineering by Design. What the hell else is it swimming beside down there? Dave Mantey says, neat.